Okay, good morning, everyone. I hope you guys all had a good spring break and you're ready for the second part of the semester. Please have your camera on because, as I said a million times before, and now it will help me if you have your camera on. Okay, so please do it. All right, so before I get going, do you have any questions? All right, so what I'm going to do today is I'm going to review quickly polar coordinate with you. So we're all on the same level. So I want you to review that, and then we're going to start chapter 9. So we're going to do a quick review for polar coordinate. Did you guys do any of your homework? Be honest. No, yep. All right. So we're going to review polar coordinate and then we proceed. So we review polar coordinate. Okay. All right. So you guys help me as you move on because we did that. So I'm reviewing it. So what's the polar coordinate? So the idea is that we have two ways of locating points in the plane. One way to locate points is by telling you the x and y coordinate that we call them the Cartesian coordinate. Another way to locate point in the plane is by giving you what we call polar coordinate. So let us remember quickly how those are defined. So this is a point in the plane. That's a point P. And this point have what we call the Cartesian coordinate, x and y Cartesian. Okay. Cartesian coordinate. And which are your regular coordinate. This is the x and this is the y. Okay, that's the Cartesian coordinate. Then every point is going to have a new way to locate it. And this way of locating it is the following. If I give you the following two info, I tell you the angle that the point OP forms the positive x-axis, and I tell you the distance from 0 to P, then r theta, those two, will be called the polar coordinate. Okay, so the polar coordinate, so if P point in the plane, any point in the plane, and r is the distance from the origin to P, and theta, the angle between the positive x-axis, and that's important, positive x-axis, and OP, then r theta are called the polar coordinate. Polar coordinate. So it's just a way to locate a point in the plane. So if I can locate a point either by giving you the x and y or by giving you the r and theta. So it's a way, as I said, just basically locating point. So quickly, I'm going to give you points in polar coordinate and we're going to draw them. So sketch the following point given in polar coordinate. Sketch the following point with the given polar coordinate. So let us see 3 and 60 degrees. So these are polar coordinates. I'm going to sketch them. All right. 3 tells me how far the point is from the origin, the distance, and 60 is the angle that it forms the positive x-axis. So if I want to draw this point, first I take the angle 60 degrees. So I need from the positive x-axis, that's where I start. And then I need to go 3 units away. And this is my point P. So this is the 3, and this is the point. Okay, that's how we locate the point with the given polar coordinate. Okay, let's take another point. Suppose I give you 3 or whatever, 2, doesn't really matter, minus, let us say, 100 degrees. So my question to you is, in which quadrant will this point be? In which quadrant will this point be? Quadrant 3, absolutely. This is how far, this is the angle. So from here, I need to go 100 degrees. I already, up to here, it's 90. I'm gonna go backward 100 degrees. That's the angle. And then I have to move 2 units away from the origin. And this will be my point P. Okay, so it's a different way to locate point, pure and simple. Sorry, that's a minus 100. Minus 100, it means we move this way. Right. Now, since every point has 2 coordinates, Cartesian and polar, the question is, how can I move backward and forward between them? So if I know the Cartesian, how do I know the polar? And if I know the polar, how do I know the Cartesian? Okay, so let us review the formula that relate them. So what we call this a conversion between polar and Cartesian. So conversion between polar and Cartesian. All right. So let us remember how this works. So suppose I know the polar, I want to find the Cartesian. So I'm going to go from polar first, because that's the easiest, polar to Cartesian. It means I have a point. We know the r theta. That's what it means. We know r theta to find xy. That's really what I mean by that. Okay, so let us remember the relationship. So I have a point. I know the r and the theta of it. So I know that this is r, and I know this is theta. And the question is, what's x and y? Okay, all right. If I know x and what are the x and the y? Anybody remember the formulation that connect them? If I know r, I know theta. What's going to be the x? And what's going to be the y? Quickly try to see if you can remember those. What's the relationship? R cosine and R sine. If you just look at the picture, it helps. If you ever forget the relationship, just look at the picture. If I look at this triangle right here, the cosine of theta is adjacent over r. So this is going to give me that the x is r cosine theta. Okay, so x is r cosine theta. Okay, and if you look at the picture, the sine is the y over r. Means the y is r sine theta. Y is r sine theta. So if I know the r and the theta, I know the x and I know the y. Okay, so quick example. Even though this is in the first quadrant, but this idea holds everywhere because of the definition of sine and cosine. In other words, if you guys remember at the beginning of the semester, if you have a point on a circle of radius r, the coordinates are always arc cosine, arc sine. That's actually what we did early on in the semester. That's really what was going on because of the definition of sine and cosine. So, quick example. Find the Cartesian coordinate of the following point. So I'm giving you the polar, 2 and 50 degrees. So the unit is, the angle is in degrees, so we have to put our calculator in degrees. So here is my point. I like to draw it. I always like to draw my point. That's my 50 degrees. And that's from here to here, it's the 2. And the question is, I need the x and I need the y. That's what I'm after. All right. So I use the formula verbatim. X is 2 cosine of 50 and y is 2 the sine of 50. So this is equal to, this is equal to, at this stage, so start please picking up your calculator and help me out. All of you, not 1 or 2. Okay, I have Aaron, 1.28, thank you. And what do you get for the y? 1.53. Okay, so I know the r and theta, so it means here, that's the 1.28, and that's the 1.53. Okay, so we know the x and y, and we know the r theta. Now, another example, but now I want the exact value, just to bring up some old things we know. So now find, let me take another piece of paper. The same question, I'm going to give you the polar, you have to give me the Cartesian, but now I need exact answers. So find the exact coordinate, the exact Cartesian coordinate of the point with polar coordinate so I'm going to pick 3, and here I'm going to pick 2 pi over 3. Okay, and I want the exact value because I want you to remember a little bit some of those values. All right, so first, I always like to draw the point because it's always helpful for me. So it's 2 pi over 3. Now 2 pi over 3, it's pi over 3 is like 60. So that's going to give me 120. So it's always, again, nice to know exactly where I am working. So this is 120 from here, or 2 pi over 3. And this is, we are 3 units away. And the question is, we need to find the x and the y. All right. The formulas hold regardless which quadrant I am in. So my x is always 3, that's the r, cosine 2 pi over 3. And my y is always 3, sine 2 pi over 3. Okay, so since I want the exact value, and I have here the exact, I have to remember what's the exact value of cosine 2 pi over 3. So if we remember our unit circle, that's why I'm bringing this up, just to remind you the unit circle. If I remember my unit circle, you remember all those unit circles. And if we had pi over 6, pi over 3, so if you remember, I don't know, so this is pi over 6, so my unit circle. And the angle here was square root of 3 over 2, 1/2. These are the values. Pi over 6, things changed. 1/2 square root of 3 over 2. 2 pi over 3, so that's pi over 6. 2 pi over 3 was right there. Okay, as I said, this is to remind you. So this is the 2 pi over 3. So 2 pi over 3 is going to be these are symmetric to that. It means the x coordinate is going to be minus a half, and the y coordinate will not change. Okay, so these are the unit circle. Okay, so now I want the exact value. It means this is going to be equal 3 times cosine 2 pi over 3 is minus a half. Means this is minus 3/2. Of course, that's what you get if you use your calculator, but I want them exact to bring up the unit circle again. And this is 3 sine 2 pi over 3, which is the square root of 3 over 2. So these are the exact values. If I want to ask you the exact value, it means I want you to bring the unit circle back into the picture and find them out. Very much. All right. So if I know the polar, I know the r and theta, find the x and y is actually not hard. Now we're going to go backward. If I know, so from the Cartesian now to polar. To polar. Means I know the Cartesian. I know the x and y. I want to find the r and theta. Okay, so we know x, y. To find r theta. Okay, all right. So again, I go back to my picture here. Okay, and this is my point. This is my x, and this is my y. And this is my theta. Okay, what do I know? I know x. I know y. I know this and this. I need to find r, and I need to find theta. All right, first let us see how to find r. To find r, we have to remember the Pythagorean theorem, which tells me that the hypotenuse square, because this is a right triangle, so Pythagorean theorem works, is x squared plus y squared. That's Pythagorean. So this tells me immediately what r is. So r is the square root of x squared plus y squared. So you can either remember it like this, memorize it like that, or just remember what it means. So that's r squared. Now for theta, even though I do things in the first quadrant, everything will work in every quadrant. If I look at the first quadrant, I want theta. The tangent of theta is the y over x. Okay. This will allow me to find theta. But as I said last time, and I will repeat this time, and I will explain a little bit what's the problem with that. So you don't have to write, but I want you to listen a little bit. So this gives me the tangent. The question is to find the theta. So theta will be the arctangent, but there is a problem with using arctangent immediately. And the problem is the following. My theta could be in the first quadrant. My theta could be in the second quadrant. When I find the arctangent of something, of an angle, what I get is only the angle, nonsense. So find the arctangent of any number, let us say of 0.3. What my calculator will give me the angle in the first quadrant or the fourth quadrant. It means the arctangent is the angle between minus pi over 2 and pi over 2. So regardless what I put in here, I get either the angle here or the angle here. But now, what if my angle happened in the fourth quadrant? How can I find it? The arctangent won't give me that. It will give me the one in the first quadrant. So if my angle happened in the third quadrant, what I'm going to do, I'm going to take the angle that my calculator gives me and add pi to it to be able to get the angle in the third quadrant. Because arctangent only gives me the one in the first. If I want the one in the third, I need to add my pi. So if theta equal, tangent theta is pi over x, then theta would be the arctangent of y over x as long as theta is in the first quadrant and in the second quadrant, because that's what the arctangent give me. If theta happened to be and in quadrant 4, if theta is in quadrant 2 or in quadrant 3, then I had to add a pi to the arctangent. Otherwise, I will not get the arctangent. I will not get the angle. I will only get the angle. The calculator give me the one in the first quadrant. I have to get the pi to get what I want. All right, so now we'll do two problems along those lines. So find the Cartesian coordinate. Sorry, find the polar coordinate of the following point. So first, the following 2, 4. So those are Cartesian. And when you have to go convert from one polar system, one system to another, please sketch graph first. Without a graph, you will be absolutely lost. So 2, 4 is Cartesian. It means this is my 2 and this is my 4. I need to find the polar. Means I need to find the r and I need to find the theta. All right, let's find the r first. R is easy. R is the square root of x squared plus y squared. Means the square root of x is 2, y is 4, the square root of 20. So I'm just finding the r. Now I need to find theta. Tangent theta is 4 over 2. Means this is equal to 2. And theta is in the first quadrant. It's important to know. How do I know? Because I graphed the point. So theta now is exactly the arctangent of 2, because the calculator will give me the right angle if I am in the first quadrant. So now what's arctangent of 2? Now let us say we put our calculator in degree. I don't know which one mine is. Okay, I'm going to put in degree. Give me the answers. So tangent inverse will give me that angle. All right, I'm getting 63.43 degrees, which is slightly makes sense that this angle is almost 63. Right, so to find, so the polar coordinate are square root of 20, so polar, and 63.43 degrees. So if I go back to my point here, this point will have two coordinates. 2, 4, those are the Cartesian coordinate, and square root of 20, 63.43, these are the polar. It means the r and the theta. Okay, example number 2, and you have to do it yourself. Suppose I give you the following point in Cartesian. Suppose I put 2 minus 4. Find the polar. All right, please get going. You have 1 minute to do it. And one of you I will pick to give me the answer. Even though all of you are hiding your faces, but I will pick one of you. When you find your answer, please put them on chat for me. Okay, not the angle, I don't like the angle. You did not sketch the point. You did not sketch the point. Step 1, sketch the point. Without sketching the point, you're not gonna give me correct answers. Okay, anybody else? Okay, anybody else? Oh, sorry. The first student gave me the correct answer. My apology. Okay. All right, I'm gonna sketch the point. Yeah, it's my mistake. 2, 4, 2, and minus 4. That's my point. So that's right there. Okay, so we have very well my point. So now we have to find the r and the theta. Okay, the r is the same. The r is the square root of x squared plus y squared. It means the square root of 4 plus 16, square root of 20. Now for theta, tangent theta is the y over x, which is minus 2, and theta is in quadrant 4. Because I know, so that's theta. So now you can either see theta negative or you can see theta positive. It depends, whatever you want. No, minus 63. Okay. All right, so what's going to be theta? Theta is going to be, since I am in quadrant 4, the calculator will give me the correct negative answer. It's the arc tangent of minus 2, which is minus 63.43. Okay. So my point is now square root of 20 minus 63.43 degrees. If you want a positive number, you just go 360 minus that. Okay. Now, my last problem along those lines before I move on is 2 minus 4. So my point is 2 minus 4, that's in Cartesian, find the polar coordinate. Okay. Again, I give you a minute for that, and then I proceed. Sorry, did I give you the same one? Why I insist on giving you that point? My apology. You guys should tell me that's the same one as before. And that's not what I want. Minus 2, 4. Sorry about that. Yeah, you should say that. You should scream and yell. Again, sketch the point first. Any answers? Yes, yes, write them. Okay. Any answers? Okay, Anthony, can you talk?
Yeah, I'm still working on it. Hold on.
You're still working on it? Okay. Why were it taking you so long?
Yeah, I was writing it down, but I'm pretty sure it's just the same thing, no? As the last one.
Not the same thing. In
Well,
which
it's not the same
quadrant is your
thing.
point?
Quadrant 2.
Very well. How will this affect the picture? So first, let's
Uh,
draw it. It's crucial. So it cannot be the same thing as last problem, because last problem, my point was in quadrant 4. So this is -2, and this is my 4. Okay, so that's the point I'm after. Okay, so what is the R? What is the R?
Square root of 20.
Square root of 20. Nothing changed. It's exactly like before. R is square root of 10. Now, what's tangent of theta in this problem? It's the y over the x, right?
Yeah.
Y is a 4 over -2. It's equal -2. My theta is in second quadrant. So we have to be very careful with that. So if I compute arctangent of -2, I'm leaving here an empty spot for a reason. Okay, I'm leaving an empty spot for a reason. Arctangent of -2 is going to give me -63.43. Am I right?
Yeah.
Is this my theta, all of you? Can this be the value of theta?
No.
No, because -3 is right there. That's why I cannot use arctangent immediately, because that's where this is the -3. But that's the point I want to write here. So to get that, I add the pi or the 180 in my scenario. That's really, I have that, because the calculator will give me the one here. If I want the one, this one, that's the one I'm interested in, because that's where theta, I had to add 180, because those 2 points have the same tangent. So this is equal that plus 180, which is one of your classmates gave me the correct answer, 1.16.57. Okay, that's really what's happening in this scenario. You have to add 180 to get the angle in the right quadrant. So you always ask yourself which quadrant I am in, to be able to get the right answer. So the polar coordinates are going to be square root of 20 and 116.57. That's really. And remember, the tangent has the same value for, usually tangent theta in general is the same as the tangent. If you take an angle and you add pi to it, you do not change the tangent at all. And something we've seen at the beginning of the semester, you don't change the value of the tangent if you add 180 degrees. So -63 and -63 plus 180, which is the pi, have the exact same of the tangent. That is, the tangent of both angles is exactly the same. Okay, so that's how we do the conversion from.
I stepped away for my laptop a quick second, but where did you get the square root of 20 again?
Oh, sure. It's x squared plus y squared. What is x squared here?
4.
Right. What's y squared?
16.
So what's we get square root of what?
Oh, okay.
All right.
Okay, gotcha. Thank you.
Any other questions? So please be careful with this idea, because that's why I thought it's a little bit harder, because we have to think. We're solving tangent theta equal -2. So to solve it, our tangent doesn't do it all immediately. It does it when I am in quadrant 1 and 4. 3 and 2 and 3, I have to add my 180 or my pi to get the problem. All right, the other thing we're going to do in this section before I move on, hopefully I can move on, is something called sketching. I'm going to do simple sketching in polar coordinate. Okay, sketching in polar coordinate. All right, suppose I tell you the following in Cartesian. Let's say in Cartesian. Suppose I can tell you sketch all points x, y in Cartesian. So when I use x, y, we can understand Cartesian such that, let us say x equal to 1. Okay, in Cartesian. What do I mean by that? What do you get? Back to you. So sketch all the points that satisfy x equal to 1. What do you get when you sketch those points? Come on, guys. So all the points that have the properties that the x component is 1. So if I'm sketching all the points that have this property, it's a line, right? Which line? X equal to 1. So it's this line. It means all the points on this line. It means I'm sketching all the points such that the x component is 1. So no matter what the y, the x is 1. So this could be 1, 2, 1, 4. I'm sketching all the points that have the property x equal to 1. I get the line x equal to 1 in Cartesian. Now, I want to do something similar, but I'm going to work with polar. So suppose I tell you the following. Sketch all the points. So part 1. Sketch all the points r theta. So it means the point r in Cartesian now. Sketch all points r theta such that r equal to 2. Sketch all the points such that r equal to 2. What do you think I'm gonna get if I do that? I'm letting you think a little bit. All the points whose coordinates satisfy r equal to 2. Okay. R, remember, 4 separate points? Not really, a little bit more than that. What do you mean 4 separate points, Aaron? Which are the points that you're thinking of?
I'm thinking that there would be a point in each quadrant, so it would
Which
form a
point?
circle.
Okay, give me one of them.
Like it could be like 240.
240. Okay, that's nice. I don't mind that. So it will be this point. Let us say this is 40, correct? That's what you mean?
Yeah.
Give me another point.
2 negative 40.
I don't mind that. Why did you pick 40?
Because it's the most symmetrical. I guess I could have went with 45, but 40.
Okay. So this point satisfies this condition, right?
Yes.
This point satisfies your condition, right?
Yeah.
I want all of them.
So then you could you do negative 240 or no, because 2 has to stay positive.
Right, because it's a distance. If you take calculus 2, then you will learn what we do with negative 2. For now, we are assuming it only positive. Go ahead.
I'm lost from there.
But you're on the right track. What if it's 30? Why did you take 40? Suppose you take 30, right? You get this point. From here to here, it's 2.
So it would be all the angles within the quadrants.
So when you sketch all of them, what do you think you're gonna get though?
A circle.
Exactly, you're gonna get a circle. Now we're talking, because you can take all the angles, not 1, not 2, all of them. So what we're gonna get is an honest to goodness circle. every point on this circle. Circle of radius 2, so we're gonna get a circle of radius 2. Crucial. Every point on this circle, every point has the properties that are equal to 2. Every point on the circle, the r is equal to 2. And that's really exactly what we are doing. And that's the importance of polar coordinate. It's an easy way to describe a circle. So I can describe a circle that all the points whose polar coordinates satisfy are equal to 2. It's a very easy way to describe a circle. Okay, I'm going to move along the same line a bit faster though. Suppose I tell you sketch all the points. R theta, such that R is between, let us say, 1 and 2. Means I want the radius r. Basically, it means I want all the points whose distance to the origin is between 0, 1, and 2. Because r is the distance. I want all the points whose distance to the origin is between 1 and 2. What do you think I will get quickly? So r is the distance from the origin. All the points whose distance from the origin is between 1 and 2. A jagged circle with different radiuses. Oh boy. What do you mean by jagged circle? Anybody will have any idea? It would be a ring. All right, that's okay. Anybody beside that? Anybody else? Okay, 2 circles. All right, so it's going to be 2 circles. So all the points, their distance is between 1 and 2. These are the points under the distance. So I'm going to take first the circle of radius 1. And then I'm going to take a circle of radius 2. And what are the points? So that's circle of radius 2. What are the points I'm interested in? It's 2 circles, but it's everything between the 2 circles. Everything such that the distance is between 1 and 2. So if this is 1 and 2, I'm going to ask you a question. If I take a point here, does this point satisfy this condition? Yes or not?
No.
No. If I take a point here, does it satisfy this condition? Yes or not? If I take a point here,
No.
why not? If I take this point, does it satisfy the condition? It means is the r, is the distance between 1 and 2. From here to here, you have 1. From here to here, you have 2. So the distance between, so this is 1 and this is 2. So if a point is right there, that is the r, it means the distance from this point to here is between definitely 1 and 2. So it satisfies this condition. If I take a point here, does it satisfy its condition? It means it's the r, you can call it whatever you want. So is the r between 1 and 2? The answer is yes. So what's the picture? What's the graph? I'm going to shade it. That's the picture. And now you guys are coming up with different name. Ring. I accept that. It's the shaded area. Okay, one student called it looks like a donut, a flat donut. Somebody who took a donut and flattened it with their hands. If you want, that's a possibility. And I mean, sometimes in math we call it annulus, if you want, because it's like a ring. So whatever you want to call it, but that's the picture you get. All right. Now I'm going to give you two more pictures. I want to see what you guys have. Sketch all the points. So R represent how far we are from the origin. So now sketch all point. No, two circles. No, usually I will ask you to shade the region. Okay, and then there will be no confusion in the language. All right, I will ask you to shade it. So sketch all the points r theta that satisfy the following. The condition, or such that, or that have the property that satisfy the condition theta equal, let us say, pi over 3. Okay, so I want all the points where the angle is pi over 3, all the points that satisfy this condition. And please, I want all of you to participate, not the same student. So think about theta to represent the angle. So all the points whose angle is pi over 3. What do we get when we sketch those? Use any language, I mean, any possible way you can express yourself. All right, I will pick one student, see what they'll come up with. Anybody want to volunteer before I pick a student? Okay, Angelina. 2 points, because if you have a radius, it changes the number. If you tell me 2 points, you tell me which points. Jacob, can you talk?
Yes, I can talk.
Okay. Tell me why you told me 2 points.
I actually am thinking about why I said 2 points now, but I know there's a point pi over 3 in the first quadrant. And then I thought there was a second one, but I might be wrong about that because I'm.
Okay, which point? Please, all of you, pitch it so you understand.
Would be pi over 3 is.
Remember, R could be anything.
60 degrees, I believe.
Yeah, but what is the point? I mean, 60 degrees does not define a point. In polar coordinate, you have to give me 2 things to define the point. You have to give me the R and the angle. If you tell me 60, I tell you what do
Pi
you
over
mean?
3 is with radius 1.
Okay, so 1, for example, and 60.
Right. So it'd be radius 1, 60 degrees, which is pi over 3.
So
But-
this point.
Right.
Why you took R equal 1?
Because that point's in radians and you can only have that on a unit circle.
But did I give any restriction on R?
No,
My restriction is on what?
theta.
Theta. What if I took the radius 2 and the angle pi over 3? This point. Does it satisfy the condition? Theta equal pi over 3.
I thought about that as well, but I figured that the radius would multiply theta when you tried to.
No, this point. This point, that one.
Technically, no.
Suppose from here to here you have 2.
Right.
Does this point satisfy the condition theta equal pi over 3?
Right. It does. Because
It does.
it's still
What?
a 60-degree angle.
Right. What if I take that point? All of you. Does this satisfy the condition theta equal pi over 3? I want answers from the whole class, not only from Jacob now. What if I take that point here?
Yes.
What's going to be all the points? It will be this line. It's not a complete line, it's this one up to infinity. Sometimes you call this a ray.
Right.
Okay? Every point on this line satisfy theta equal pi over 3. Any of them. Because that's the angle. If you give me a point, any point here, the condition is theta equal pi over 3 is satisfied. So it's just really, it goes all the way to infinity, is just a ray. Not the whole line, because the theta is not pi over 3 anymore. So it's only a ray. That's why I did not say a line. I said the ray because we started from 0 all the way up. So these are the points that satisfy. All right. I will give 3 more. So I'm only sketching simple picture, but I think we need something. It's good to get at least those. Now sketch all points are theta. All the points are theta that satisfies the following condition. Theta is between 0 and pi over 3. All the points where the angle, what I said, their angle is between 0 and pi over 3. Okay, again, I want all of you to think about that. So I'm allowing R to be anything you want, but I'm putting condition on the angle. So it's a piece of pi between the origin and pi over 3. Yeah. Okay. Okay, Asia, would you like to give me, what do you think it's gonna be?
I think it'd just be like a shaded in triangle between the 2 points.
Right, so this is, yeah. That's theta equals 0. And pi over 3 is 60. That theta equal pi over 3. It's everything between it. It goes all the way to infinity. That's the shaded area. Okay, every point here, its angles is satisfy the condition between 0 and pi over 3. Okay, exactly. It will be an awesome piece of pi. Yeah, an infinite piece of pi. Okay. Now I'm going to mix 2 ideas together and see what we come up with. All right. So now, sketch. So I repeat that one of the benefits of the polar coordinate is that they help us to really describe those regions in a very easy way. I mean, I can give you this region and tell you, okay, describe it in polar. You tell me, then you know that's all the points with polar coordinate are satisfy this condition. So now I'm going to ask you the following. Sketch all points are theta. Such that satisfy the following condition. So I want them to satisfy the condition that R, it means how far away they are from the origin, between 2 and 4. So I want them to be the distance to the origin between 2 and 4. And I want the angle between 0 and pi over 3. How does the picture look like? So I want you to analyze it yourself and then figure it out. Like a melon. Oh boy, you guys are giving me so like a melon. Okay, I ate a melon yesterday. Slice in ¼ 1. This is, no, I want something more precise. ¼ of a ring. Okay, when you shade it, I think you have the right idea. Anybody else? Anybody would like to express anything? Alex Baginski, do you have any idea? Alex, are you with us?
Yes,
Okay.
I would. I can't really come up with a good description.
You don't have to, just tell me what would you do.
The first thing I would do is I would find the angle
Mhm.
at between 0 and pi over 3. And then from that angle, I would look for the section of the radius that's between 2 and 4.
Okay, so this is this is 2, right? The radius 2, and that's a circle of radius 4.
And then from there, I would only take that small kind of curved part between 0 and pi over 3.
This one?
Yeah.
Absolutely correct. That's the shaded region. Okay, so this is the region that you are interested in, because if you take any point on this region, any point, how far it is from the origin, between 2 and 4. For any point in the ring that we did before, satisfy the condition R between 2 and 4. But I also want the angle between 0 and pi over 3. I want to limit the angle. So this will basically give me this region. So every point here satisfies 2 conditions. How far it is from the origin? Between 1 and 2. What's the angle? Between 0 and pi over 3. And that would be the ring if you want, but it's not the whole ring. It's part of a ring. It's the ring between 0 and pi over 3. All right, so before I move on to chapter 9 and start it today, I'm going to ask you now the following. Give an inequality. So I'm going to shade the region, and I want you to give me the inequality that describes the region. Give inequality in R and theta that describe the following region. Okay, so I'm going to draw a region, and you have to give me an inequality based on the problem that I did, a minute ago. So it's going to take me a minute to draw it. Whatever, something like 2 pi over 3. Okay, so that's my region. Sorry, I think this angle is not very clear. So this is theta equal to pi over 3. Okay, I want you to give me an inequality based on what I did a minute ago to describe the following region. That means you take a point here and you say, okay, what characterizes the point? What characterizes the R in this point? So what characterizes its distance from the origin? And what characterizes the angle? What limit can we put on both of them? Okay, who's ready? Okay, Erin tells me, okay, the theta is between, okay, so the theta, absolutely correct, is between pi over 6 and 2 pi over 3. That's the angle. So every point here, the angle have to satisfy this condition. But that's not enough. That's not enough. R also has to be between 2 and 3. Both conditions have to be satisfied. Yeah, exactly. Both condition has to be satisfied to characterize this region. One of them will not do. If you put only that, I tell you, but you're giving me this point. I don't want that. If you only give me that condition, it means you give me a point right here. I don't want that. I want both conditions to be satisfied to describe this region. All right. So one of the benefits, one of them, polar coordinate will be used tremendously for those of you who will continue. You will be using them a lot. But one of the good reason about it, the main reason is that they describe those shapes in a very, very easy way. So I can describe those circular shape in an easy way using the idea of polar coordinate. Those shapes will be very hard to describe if we use what we call Cartesian coordinate. All right. In the last 15 minutes, I want to start section 9.1, which is, we've seen part of it, which is what I'm going to be doing today, is something we've seen it, but we're going to put a more graphical point of view to it. So we're going to add a graphical point of view. So the idea is what we call trigonometric equation. Trigonometric equation is those equations that we've been solving. So a simple trigonometric equation is, let us say, cosine t equal 0.3. That's an equation called a trigonometric because it involves the cosine. So we're going to solve this equation today, but I'm going to also interpret the solution using the graph of the cosine function, which is the little bit that we're going to add to the picture. And we're going to do more. We're going to solve something like cosine 2t equal 0.3, something else. And one of the things we'll be able to solve also next time is, if you remember the story problems at the beginning of the semester, if you are on a Ferris wheel and the Ferris wheel is moving, and this is the height above Ferris wheel, and let us say I give you a certain time, a certain height, I might come up with a height, I tell you, when does the Ferris wheel reach this height? And we'll be able to solve those type of problems. So, but today we're gonna do the first easy one. So trigonometric equation. All right. So everything I'm gonna do is almost. That's why I'm using the last 15 minutes. Below is the graph of cosine x. So let us remember the graph of cosine. The graph of cosine starts at 1. So that's the highest value. The minimum value minus 1. It's 0. We know that the cosine 0 at pi over 2 and 3 pi over 2. And it's periodic of period 2 pi. So that's really the period. That's a cycle or the period. Okay. So that's the graph of y equal cosine x. My first question is, find the values of x. So this is y equal cosine. I'm going to put it in terms of the graph, such that y equal 0.3. Okay. So what am I asking you to do? This is y equal cosine x. And this is, so if this is 1, this is 0.5. What I'm asking you to find is the following. If this is 0.3, that's 0.3, and this is my ruler right there, 0.3. I'm asking you to find all the x's. The picture will be important. I want you to find all the x's such that, sorry, my line is not straight. Okay, right there, it should be here. Okay, all the x's such that cosine x equal 0.3. It means this is 0.3. I want you to find you know, I have the output. I'm basically going to ask you to find the input, this one and this one. That's really what I'm going to ask. All right, so let us remember how do you do that. Such that y equal and x between 0 and 2 pi. So it means basically I need to solve cosine x equal to 0.3. So we're basically solving this equation, but this time what I am adding is I'm actually want you to see the solution graphically, and that's really the important part here. Okay, so solving cosine x equal 0.3 is basically taking the graph of y equal cosine, that's the 0.3, and asking which angle give me a cosine of 0.3. Now, the way we are going to solve it is exactly the way we've been learning how to do it. It means we're going to use the unit circle solve, and we're going to use the arc cosine, and unit circle. That's how we're going to solve it, nothing new. Okay, so sorry, I know that you didn't see a word here. So I'll rewrite it. So we're going to use the arc cosine, and the unit circle to solve this. Okay. All right, so let us see. Cosine x equal 0.3. So this is my unit circle. So the cosine of x equal 0.3. So remember, the cosine is the x coordinate. That's the 0.3. A lot of you are still, so that's the 0.3. So I'm finding the angle whose cosine is 0.3. There are two angles. There's this one, and there is this one. Okay. Now, so cosine x equal 0.3. It means x is in quadrant 1 or in quadrant 4. Okay. So let us solve it. The calculator will give me x equal arc cosine of 0.3. Now, since the graph is in radian, I'm going to put my calculator in radian and evaluate those. And what is math here? Okay, so I need cosine inverse of 0.3 in radian 1.26. So it's a little bit over 1 radian, 1.26. So we're talking about 70 degrees. So that's really what the calculator will give me. Now the unit circle will give me the other value. So this is my first value. And the unit circle will give me the second value. Now, because I'm going to have two values, I'm going to label them. So I'm going to call this x1 if you want, because just to label them, I have two values. x1, I'm going to call this x1. And what's the other value? Back to you. Okay, that's the picture. That's everything. What's the other value? So what I'm adding is that I'm labeling them because I have two of them. Okay, we're going to call one x1 and one x2. What's the other value? I want all of you to figure it out from the unit circle. Come on, guys. That's the picture. I have this one. This is 1.226 radian. What's going to be the other one? Arc cosine of minus 0.3, but I want them between 0 and 2 pi. I don't want arc cosine anymore. I want the picture. The arc cosine, I've used it. How can I get it using the picture? So that's 0.3. The calculator gave me that. How can I get the big one? Let's use the picture. What's the big one? Exactly. It's 2 pi No, it's not pi. It's 2 pi, take away 1.26. I stop because you guys are not following. Why it's 2 pi minus 1.26? Okay, why 2 pi? Okay, this is your circle. I'm gonna draw a huge circle here. That's your circle. And this is 0.3, almost. That's not quite 0.3, but I want a big picture. This is the 1.26. That's because that's a unit circle. The cosine of 1.6 of 0.3. Now, the other angle that have the same cosine is this one, from here all the way up to here. But how can I find this? It's the whole circle, which is the 2 pi. You take away the 1.26. So that's the 2 pi minus the 1.26. That's your other angle. Okay, which is equal to, and that's where I pick up my calculator and compute it. Minus 1.26, which is 5.023. Okay, so it's the whole circle minus 2 pi. So I have two values. So this is the x1 and this is the x2. Now I'm going to mark those on the graph of cosine. So the question is, find all the points such that satisfy cosine x equal 0.3. So on the graph, which point I'm looking for? This point. This is the 1.26. That's the x1. That's 1.26. That's the one the calculator gave me. And the other value is this one. This is x2. And even from the picture, I know that 1 should be between 0 and pi over 2, which is we know in quadrant 1. And 1 has to be between 3 pi over 2 and 2 pi, which is could be in quadrant 2. And x2, this is going to be 5.023. Okay. So solving cosine x equal 0.3 graphically, it means you take the graph of cosine and you look for the angle whose cosine is 0.3. So 0.3 is an output value now, and you're looking for the input that gives you 0.3. So that's how we can visualize those graphically. Now, suppose I ask you the following questions. I want more values. Find all values x such that x between 0 and 4 pi and cosine x equal 0.3. In other words, can I find more values who have for cosine 0.3 and between 0 and 4 pi? In the first one, I found 2, 1.26, and I found 5.023. Can I find more of them? Can I find all the angle between 0 and 4 pi? Back to you. So, show you the picture on the unit circle. I found 1.26. This is 1.26. Okay, and I found another one. I'm drawing two circles so I can explain the picture. So this one is 0.3, and I found another one here. 0.3, and this one was 5.023. Both angles are between 0 and 2 pi. Now, who can give me more angles? Who can give me another angle? Not this one and not that one. Who can give me more angle? Okay, see what I mean? Means if I start from 1.26 and I add 2 pi, will I get another angle with the same cosine? Yes or no? Yep. So if I take another angle, so I can find another one. So let's write this down. So we have x1, one angle, which is 1.26. Then I can have x2, these are the ones I have, using the unit circle. So if I want more, I take this one and I add 2 pi to it. So I wrap around the circle one time, and then I'm gonna get another angle, and this would be between 0 and 4 pi. And then I can get a fourth one. I add 2 pi, or I can use the other angle and I add 2 pi to it. And this will give me 4 angles. So I have not only, so between 0 and 4 pi, I'm going to have 4 angles that have for cosine 0.3. And then I keep going on and on and on. Okay. So, all right, I have to stop right here. So for next time, I'm going to reassign the problem from polar coordinate, and then I'm going to assign problems along those lines. Please do them or you will be lost next time. All right. The class is dismissed. If anyone has questions, please stay.
Have a great day.
Thank you.